Hello class, today we are looking at the difference between precision and accuracy. Your essential question: how do I determine the precision of a calculation and find significant digits? Learning intention: I'm learning the difference between precision and accuracy and how to find the number of significant digits. So you've got two warm-up questions. Can you pause the video and answer them now, please? Well, I hope you tried. Do you remember what rational numbers are? Rational numbers can be written as a fraction. Remember, if it's a decimal, it will either terminate or repeat. For the next one, you have to start by doing your distributive property. You distribute to both of those terms. 2 times x is 2x. Bring your minus down. 2 times 3 is 6. Plus 5 equals 45. Okay, hopefully you were able to get that far on your own. Now, are both sides simplified? No. I can still combine -6 and +5. 2x. 6 minus 5 is 1. Keep the negative sign. Minus 1 equals 45. Now I'm ready to solve. I solve by adding 1 to both sides. I've got 2x is equal to 46. I will divide both sides by 2. And I get x is equal to 23. Okay, 23 minus 3 is 20, times 2 is 40, plus 5 is 45. I did the check and it is correct. Okay, so let's look at what Mickey and Danny are doing. Mickey and Danny are mounting a shelf on the wall and need to determine where the mounting brackets should be placed. To ensure the shelf is level, they need to make measurements that are as precise as possible. What subdivisions of an inch could be involved in this situation? So let's take a minute and look at our ruler. Here's an inch. It's divided into, here's fourths. Each fourth is divided into half again, which would make each of these 1/8. And finally, you divide the 1/8 in half again and you get 1/16. So your inches could be done in 1/16, 1/8, 1/4. What do you think? What would make that shelf look level? Would you want it to be 1 inch off? Oh no, that would be very unsettling. What about 1/4 of an inch off? That would still be very obvious. So for an inch, I would use either 1/16 or 1/8. Okay, that's going to get you really close. What about a centimeter? What is a centimeter divided into? Well, they're divided into tenths. So how much do you think a centimeter could be off before we would notice? 2 centimeters? 5 centimeters? What do you think? If I'm looking over here, 5 centimeters is a little bit less than half an inch. I don't think I would like that. If you said between 2/10 of a centimeter and 3/10, that would probably be really, really close and make it look really well. Okay, why? Why would you do it there? Well, for me, it would be because then it would hang level and it would not bother me when I looked. So with that, hanging that shelf, you'd really, really, really want to be looking at that. So how would your answer changed if Mickey and Danny used a tape measure where the smallest marked subdivision are 1/8 inch or 1/2 of a centimeter? So I guess what they're asking us to look at, which is smaller, 1/8 inch or 1/2 a centimeter? Okay, here would be 1/8 of an inch. Here would be 1/2 centimeter, which is bigger. Right here is 1/8 of an inch. Right here is 1/2 a centimeter. Which one's bigger? The 1/2 a centimeter is bigger. So I would use 1/8 of an inch. Because it's smaller. Okay, now we're going to look at the difference between accuracy and precision. I want you to think about a football player. You've got a kicker on the team, and he kicks that football, and he does such a good job because it hits the same place every time. He's very accurate, but is he precise? If he kicks every time and hits the bar on the that it's supposed to go through every time, so it bounces out, would he be precise? He'd be accurate because he's kicking the same place every time. But is that where you want it? So, accuracy is the closeness of a measured value to its actual value. While precision is the level of detail of a measurement determined by the smallest unit or fraction of a unit that can be reasonably measured. Okay, and you do need to memorize those two definitions because you will see them on our tests. Okay, so as we're looking at rules for your significant digits, all non-zero numbers are significant. So if I'm looking at the first one, I've got 1, 2, 3, 4 non-zero numbers. This would be 4 significant digits. The next one, how many does it have? How many numbers do you see? 3. This one is 3 significant digits. Okay, so those two that's pretty easy rule. Now look at there's 4 different ways you look at the zeros. Okay, the first way is zeros between 2 other significant digits are significant. So if I'm looking at this, the zeros in between 3 and 5, so I've got 3 significant digits. Okay, let's look at the next one. How many significant digits does it have? How many zeros are between those two numbers? And how many zeros are outside? The ones that are inside the two numbers you have to count. 1, 2, 3, 4, 5, 6. So this has 6 significant digits. Okay. Zeros at the end of the number to the right of a decimal point are significant. Here's my decimal point. Here's to the right. How many do I have there? I've got 3 zeros. They're all to the right. 1, 2 more. So 3 plus 2 is 5. This one has 5 significant digits. Can you do the next one on your own? Okay, this one will not count. It's to the left of the decimal. So this one is 1, 2, 3, 4. 4 significant digits. Okay, now zeros to the left of the first non-zero digit in a decimal number between -1 and 1 are not significant. We're looking between the decimal and the number. If it's to the left, it's not significant. So here's my first non-zero. These would not be significant. So this would simply be 15. So that would be 2 significant digits. Can you do the next one on your own? This 0 is to the left and in between the number and the decimal. It does not count. 1, 2, 3, 4. So this is 4 significant digits. Okay. So the last thing we can do with zeros, what if we don't have a decimal point at all? All the zeros to the end of your number that does not have a decimal point are assumed to be not significant. So if I don't have a decimal point, all I'm going to count are the numbers, plus any zeros that might be in between them. 1, 2, 3. That's all I have to count. How about over here? How many zeros are between that last number and where a decimal point would go? Those will not count. So how many significant digits do I have? Only 2. Okay. We've got a rule for multiplication and we've got a rule for addition or subtraction. Remember that your result cannot be any more precise than the least precise number. So if you have one number that goes to the tenths and one number that goes to the thousandths, you can only round to the tenth. So pause the video and see if you can fill out this number and the number of significant digits. Pause the video now, please. Okay, let's look. 1, 2, 3. This has 3 significant digits. Here's my decimal. This on the right of the decimal, I'm not going to count it. So this has 2. Okay, here these zeros will not count. They're to the right and not past the decimal point. 1, 2, 3, 4, 5. How many do we have here? We've got 3 zeros that would not be significant. So this simply has one significant digit. What about the number 300.0? All 4 of those digits will be significant because we're going 1 digit past the decimal. So this would have 4. Okay, what did you get on the last one? You've only got one number. That 0 there will not be significant. So I've got 1, 2, 3, 4. Whoa, here's my decimal. That means all of them are significant. 1, 2, 3, 4, 5, 6. So, did you get those correct when you tried them on your own? Okay, we're going to write and solve the answer in the correct number of significant digits. So first of all, we have to find the answer. So if I'm multiplying, okay, 3 times 5 is 15. I carry that 1. 3 times 2 is 6. Add that 1, and I've got 7. 3 times 0 is 0. 3 times 1 is 3. So that's my first row. I've got a second row for the 5. Okay, I've got to put my 0 as a placeholder. 5 times 5 is 25. Bring the 5 down, carry the 2. 5 times 2 is 12. Add 2 more. 5 times 2 is 10. Add the 2 that are left over and we get 12. Bring 2 down and bring a 1 up. 5 times 0 is 0, but I've got that 1 that I've carried over. 5 times 1 is 5. 5 plus 0 is 5. 7 plus 5 is 2. It's 12. Carry your 1. 1 plus 2 is 3. 3 plus 1 is 4. 5 doesn't have anything to add to it, so it's there. Now, I count my decimal points. I've got 1, 2, 3. So I go over 1, 2, 3. This is where my decimal point is. Now, how accurate, how precise can I be? Well, I can only be as precise as the least precise number. That would be right here. So I can only go out to the tenths. So this would be 54.3. That would be the answer you would use. Okay, on the next problem, we're going to the tenths and we're going to the hundredths. So we can only go out to the tenths again because that is our least precise amount. If we add, we just add straight down. Okay, there's nothing to go with the 5, so I bring the 5 down. 0 plus 2 is 2. Here's my decimal. 7 plus 10 is 17. Okay. Now, I can only go to the nearest tenth. It's 0.25. Do I round up or do I round down? You round up. So this is 17.3. So, you know you're successful when you can identify the number of significant digits and identify how precise your computation can be. So this is significant digits. And precision. I'm having trouble spelling precision today. Okay, please complete your practice.